All right, I think we are live. All right, hi everyone. Welcome to today's Midnight Dev Hangout. My name is Idris Olubisi, a developer educator at Midnight Foundation, and it's great to see so many of you here listening and watching live. Today we have an exciting sessions lined up for you all, and also we are going to showcase some amazing work from the community, walk through building and deploying on Midnight, and also share an update from our recent October 1st event that just happened. But then before we dive in, I want to give a quick overview of what we will be covering today. First, we have the brilliant guys from Open Zeppelin today joining us to demo Lunar Swap. Don't worry, he's going to share a lot of things, a lot of details that you need to know about that. And then that is Midnight's first decentralized exchange that just went live, and this is a huge milestone for the ecosystem. And I'm really excited for them to show you all what we have built and also what we have so far. Then I will take you through building and deploying on Midnight. We'll do our docs got updated recently, and then we'll go through all of that process. I will also showcase the new MN package that we just created, an NPM package that allow you to scaffold the experience of getting started with Midnight in minutes, right? And also what you can do pretty easy, and of course introducing you to some of the templates that is available within the project. Then after that, I would pass it over to my colleague Jay. He would share and highlight and contributions from the October 1st initiative. We have had some fantastic community participation so far, and we of course want to celebrate with you all here today. And then finally, we have a Q&A session where you can ask questions, but of course in real time, like you always do. You can drop a chat if you have any question, and then we'll make sure we answer everything. So let's get started. Now I'm thrilled to introduce you to the Open Zeppelin team, who have built something really, really special for the Midnight ecosystem, and then it's publicly available. Open Zeppelin team, thank you for joining us today, Iskandar. Can you please introduce yourself and walk us through some of the really, really cool stuff that we have to do?
Sure, thanks for the warm feedback or the welcoming. But can you guys hear me first, everybody? Good. All right. Yeah, I'm happy to be here. I'm Iskander, work with Open Zeppelin. Mainly focused my work in midnight stuff, sometimes contributing to compact contracts. If you may have not checked, please do. And but another part of my time building starter dApps. Today, I'll present the first one, Lunar Swap, which is going to be, yeah, using UTXOs for building private AMM. So we can see this next. All right, I'll pass it back to you. Thanks.
All right, thank you so much for that. I think now everyone would love to see, the demo and everything you really want to show us today. So I don't know. I think you can, put your screen up and then go for it. Yeah, I think you have your screen up. Now I think you're muted.
Sorry.
Oh,
All right, can you guys hear me now? Cool. So Lunar Swap is DEX AMM style using UTXO tokens on built on network, Midnight Network testing, the testnet for sure. It's today's goal is basically focusing on three liquidity actions, which is adding liquidity, swapping, and removing liquidity later on. They're all running on the local server, local proving server, and part of my presentation is showing a demo from the user perspective how the dApp works, and then the other part is actually for developers to look at the code and dive into compact code a little bit. Basically, Lunar Swap is a fork of Uniswap version 2 that you find in Ethereum, and that has an AMM style that has a vault, a central vault in the contract, and this collects all the liquidity, and then later on LP providers can add liquidity or users can simply swap them. We're using ledger tokens, UTXO tokens, and LB tokens, the reward or sort of the proof for LB providers. They are also shielded or UTXO tokens. The contract address is deployed on that address. Okay. For sure, Lunar 7 is experimental, not for production user whatsoever. It's just a starter application for education and demo purposes. Cool. So as I mentioned, we've got 3 use cases today. User 1 will be providing some shielded tokens and like creating a liquidity for two new tokens. And then later on, this user, if they added liquidity correctly, they will get back LP tokens as a reward. And the second thing is swapping. User 2 will go to swap those 2 tokens. And then the last thing is removing liquidity. All right, so all the circuits for the demo is 0.23 version for compact. We're working on upgrading to 0.26, so that should be available soon. The 2 users I'm using Lace Wallet preview that you can find in Chrome store. The second user I'm using actually Midnight Lace that you can deploy it or download it from the releases as a zip file. I think it's still under development, not released yet, but just you find it in the docs. Cool. So all the demos are running on Chromium, running on local proof server. Cool. And so for the first user, we've got the first user has some amount of Dust tokens and some amount of wrap BTC, and this is just I deployed that token and name it that way for simplicity. And we're going to deploy or create a new pair of tokens using these 2 tokens. And the output or the outcome from the circuit, I should have some LB tokens that represent my contribution to the liquidity. And this amount of tokens proves my contribution to the liquidity. The proving time is about 6 minutes, depending on your machine, because the constraints are pretty high. Cool. So that's the first demo I have. All right. I think. Forgive me. I think I should exit. It's a bit. All right. Sorry, the link of the video makes the slide a bit glitchy. Okay. Hello, can you open?
Yeah, I think you need to, slide mode and play.
Okay. So as you can see, I wanted to make it full screen, but somehow I can't. Maybe if I do this, yeah, or still I can't. Yeah, I'm sorry. Then we have to see it this way. So basically, first thing, we're connecting to Lace Wallet locally, and I will try to just jump a bit faster because of the time I have. Sorry, this is hard to deal with here. Okay. All right. Okay, so in this part here, I went to the pool page and I want to add 2 liquidity for two tokens. And now I'm, okay, sorry, this is not good. What the hell? Okay, so the first thing is I choose token 1 as T-Dust, and the second thing I use token wrap BTC. And then I made sure that the proving server is running. And then I will add some tokens for T-Dust and some wrap BTC for the second token. And then I will start by running the circuit for generating a proof. And this, because the circuit is quite heavy, it will take around 6 minutes, as we mentioned before. And this is basically to just finish all the zero knowledge constraint stuff. So I think I can just jump all that time. And yeah, until here, all the constraints have been passed. And soon you should see, we should see a preview from Lace again to sign the transaction. And here, this is from the interface. This, when you see the proof transaction here shows up, that means that the balance actually, the transaction actually got balanced because we're using UTXOs underneath. So the wallet has actually enough tokens to balance the transaction, and therefore you're able to prove your transaction and sign it later on. So that's what we're doing right now. So we're proving the transaction, and then it should be submitted to, or we're submitting now to the chain, and that should be, yeah. Now when we check the added tokens, we can see now the new pair that's added, T-Dust and T wrap BTC, the second one. All right. So that was the first use case. The second use case I want to show that actually user 2 will go ahead to that newly created pair and try to buy some wrap BTC from the T-Dust token that they already got from the faucet. So user 2 wants to swap some 23 T-Dust or selling, and then buying 36 wrap BTC. And this is known by the liquidity slippage balance, or the sort of pricing ratio. Cool. So that's from the second user perspective. Connecting to the wallet, the same thing. We're now on the swapping page or the trade page. Checking, all right, I have some T-Dust, I want to sell them. I want to buy some wrap BTC. So I will sell 23 amount of T-Dust, and on the other side, I'll get 63 based on this ratio. Not forgetting to open the proof server, and then we'll start running the circuit. The same thing, I'll have to just skip this pouring time, waiting for the proof to be generated. So now I will, again, whenever we see the send transaction, that means the transaction got balanced. And then we can continue with submitting the transaction on chain. Cool. So let's go a bit further. All right. It's done. Now, from the user perspective or the user wallet, you can see the 63 binding. And this is actually the new contract that I just bought from the pool. Again, these are UTXO tokens. The movement of the tokens are hidden. So nobody can know that you actually swap, but you at the end get swapped. But people will be able to see that the liquidity has changed, got decreased a little bit. You just name it, and that's it. There's a page here to explore the tokens, and then you can see the token type. I think the Midnight Lace team are already working on enhancing the usability of the wallet so that you can see the name of the token, of the UTXO token already presented for you. All right, so that was the second use case. The third use case we've got is user 1 again, who've added some LB tokens at the beginning. This time, do you want to reveal some or remove some of the liquidity back by burning some of the LB tokens? And they will get back 61 T-Dust and 163 Rapid Seal, whatever. And then, so maybe you can look right away to the demo. The same thing connecting. I'm here just showing the balances that the user had before doing this. And I'll just skip a little bit. All right, let's continue. think here is good. Cool. So we check out the pool, but this time we go to the remove, and then we check which pair I want to remove from. I choose the second pair here, and it shows up the total reserves, and this is public data. I'll put the amount of LP tokens I want to burn, and then after having the successful transaction, I would get these amounts back. All right. Yeah, opening up. Yeah, if you can see this part here, after I put like 100 LP tokens will be burned, smart contract already calculated the amount of tokens I'm expecting to get back based on the liquidity like values on the chain. Okay, and the same thing, I started to approve the transaction, and later on I should be able to sign the transaction. Cool, and then the transaction got successfully done. Now, if I get back to the Lace wallet, maybe might not be easy to recognize because of the bytes variables here, but you can see that I've got back some plus 163 of I think this is RAPBTC. I actually forgot, but one of the tokens I got the same value that we expected from the beginning back. Cool. So that was for the third use case I got today. And I think the last part here, I'm showing the public reserve or the liquidity on the ledger that got decreased after removing this liquidity amount. All right. So I think let's go to the third, continuing. Cool. So comparing just the privacy differences here, well, in Ethereum, everything is public, so there isn't something to compare about with privacy, but it's just more to see what's private in Midnight. So public, the token balances are public in Ethereum, whereas in Midnight, as we're using UTXOs, they are hidden. The LB tokens are also hidden because they're UTXOs too, but the swap amounts, I'm not quite sure about this, but I think they're partially, actually, no, they're partially hidden and partially not hidden because you can tell that the liquidity, as I said before, got changed, but you cannot know who got these tokens, right? The ownership is also shielded. All right, and the public ledger is public, or the total amount of tokens and the liquidity is public. There are some security considerations here in liquidity in LunaSwap version 1. There's something called the inflation attack. Is not actually protected against because I think for the inflation attack, just maybe remind it because maybe it's better to look at this in the code right away. I can tell you why we couldn't resolve this sort of attack. The second thing, there is an issue with UTXO total supply. Imagine with ERC20 tokens, you've got this total supply, but in UTXOs, it's difficult or it's impossible to actually recognize if somebody else burned their tokens, and then if you need to change the total supply. So this is an issue. So which means that you don't really trust the total supply. And the total supply is sometimes important for some economical equations. The last thing I want to mention is the 128 bits of size that are not as ERC20 tokens, but this is, I think, not really relevant. Maybe I need to remove this. This is maybe a general issue with that size. But anyway, so, all right. So now I want to come to maybe more interesting part for you guys looking at the codes. So the LunarSwap got open sourced today, actually. You can find it in Midnight's apps under Open Zeppelin organization. And the main idea of the repo is to have many other applications. LunarSwap is one of them. You can find LunarSwap ready implementation under this branch, E2E branch. You just go ahead there if you want to check the code that's running on in the URL. And and I have some goals to show you guys today in the code. I want to first look at the contracts, which might be a little bit complex. I will open the VS Code because it has this highlighting, so it would be easier. So I'm using 23 again. It's not upgraded to the latest compiler version. But basically, I want to show you how this complex project would look like when you have multiple contracts. Keep in mind that Compact right now is composable. You don't have sort of object-oriented stuff, like you cannot create new contracts. So it's a bit different if you're familiar with Uniswap implementation in Ethereum or in Solidity. You will see different implementation here. We're
Yeah.
exporting some types. Sorry.
Sorry a bit. Can you zoom in a bit?
Yes.
Yeah, thank you.
Is that better? Or should I do more?
One more time. Yeah,
One
it's
more
fine.
time. All right. Thanks for reminding me. Cool. So I'm just exporting some data that are useful for the TypeScript later on. And these are the ledger variables. Maybe before we look at the circuits code, maybe I'll look at ledger. What's in the ledger exactly? So I think I'll first look at the, not this one, the factory. All right, first I want to look at the liquidity. Where is it actually stored? So the liquidity is stored in this mapping function. And it's basically a map with some bytes, like some identity, and then the pair. And I'll show you the pair now. And then the reserves also in another map. And there is a technical reason behind this, because you can tell why the reserves are not just stored inside the pair. Okay. All right, so let's actually look at the pair first. I think it was here. Yeah, all right. So the pair is defining a pair. Inside the pair, we've got two tokens, token 0 and token 1 in the pair. And then we've got LP tokens, the ones that are minted to the liquidity provider. And then we have two identities for storing the reserves for each token in that map on the left side. And lastly, these are just stuff related to the prices of the tokens. I tried at the beginning as a developer to put just the reserves here inside the struct and have them as qualified coin info. But this is actually would come up with an issue at the end, because when you store coin infos in the contract, you need to make sure that they are properly stored so that they are converted into qualified coin info later on. Because this conversion has to be done from the ledger itself, which makes sure that actually there is Merkle tree index, the correct Merkle tree index of that token. In order to do this, you need to use one of the types that are ledger ADT type. And you can find this in the docs. So, and then I think almost all of the types, they have an API for inserting coin info, or yeah, inserting a coin info. And this is the way you should go when you deal with coin infos. So that was for the type or the ledger types, how they look like. And basically, the rest of the contract is pretty straightforward. The main API is adding liquidity, for example. We get some amount from the user, but we're not going to add all the amounts in the liquidity. We have to make sure that this amount of liquidity don't harm the ratio of the prices, all right, because of the slippage. And then when we get to two tokens, it's maybe a technical thing here. I'm just sorting the tokens. and the sorting of coin infos and they're basically done using the color of the token. So I'm just comparing the two colors together. So the color that's less than the other is taken to be 0, and the other one is just 1. I might maybe show you the color with the sorting function. So if you want to sort two coin infos to know which one is less than the other from the coin color, we created this custom module, byte32. That it's a module that you can use to actually do some comparisons between between bytes values. You can find this module uh, under the math library, which you can find it here. It's also open source. I think this is it might be useful for some cases. Cool, and then we calculate the pair ID, which is basically just the hash of the two types, and then we get the pair ID, and then later on we go to the router, and then the router would do maybe more stuff. We check that the values we get from the user are actually optimal. So inside this function, internal function, we're just figuring out the optimal value. And then after we got the optimal value when we get from the user, we split the coin, the amount we got from the user. We just receive the used coins based on the optimal values we calculated before. And anything, as a reminder, we reflect it back to the user right away. We send it immediately. And this is, again, to just protect the price slippage of the pair. So after this step, after receiving the tokens from the liquidity provider, we can simply go ahead and mint LB tokens for the user. And basically, the minting process is minting some ledger tokens or UTXOs for the liquidity provider. It has two main conditions. The first condition, if we're actually creating a new pair, you calculate the liquidity, and then you create, when you create the liquidity amount that we're expecting to be minted, we go ahead and mint those amounts. And if you remember from my slides, I said there's inflation risk or attack or vulnerability. And this is because of something called like one way to avoid this attack, as Uniswap have done it, is to actually mint some minimum amount of liquidity to the burn address. And this way you can actually have them all time locked. Nobody can able to change them anymore. But after trying this, I couldn't have a successful transaction because apparently Midnight GS couldn't balance the transaction for some reason. So I'm working with the Midnight GS team to figure out this part. It might be an issue, or it might be something wrong in my side. So we will see about this later. The second case in this main function is just adding liquidity to existing pair, which is basically just calculating the liquidity. And I'm really dependent on the math library here because of this complex calculation. And at the end, we've got some LB tokens minted. And finally, I just update the ledger. So that was it for the add liquidity use case. The rest of the circuits are basically similar things, but a little bit different. Yeah, so please check out the codes. Let's know if you think we can do like more optimal, how to say it, call it the constraints. If you think there's some optimization can be done or something, or there's a bug, would be interesting too. Okay. Now, after you finish the compact codes, maybe before I jump to this, I want to ask you guys how much time I left. I'm afraid I took longer.
Yeah, that's really interesting. In fact, I wanted to like continue, but I think probably we can wrap up so that we can then share the link to everyone that is interested to check out the code themselves and then go through it so that we can.
So
we have about
4 minutes, 5 minutes, less than this, more?
1 or 2 minutes.
2 minutes.
Yeah.
Okay, cool. So just after you finish the deployment, after you finish your compact code and you build it, you need to have some, well, the way I use to deploy the contract, I build a CLI tool package. You can find it right there. And I used it for deploying using my address. And I also created an API layer that's pretty useful for integration with the front end. And it really just defines what I'm expecting from that contract. And then when we go to the UI part, you go inside the apps, and then this is the whole UI stuff. I think the most important things to note, when you want to connect to a Midnight network, you need to make sure there's Lace Wallet deployed. And then when the Lace Wallet is deployed, you can pretty much start initializing the providers that are needed for this. I think you may need like 5 providers, if I remember. So there is you need to initialize the ZK provider, the public data provider, the proof provider. Most importantly, the wallet provider that actually balanced the transaction. If the balance here didn't work properly, you won't be able to sign the transaction later on. Then lastly, the midnight provider, which actually submits the transaction for you at the end on the chain. So that was it. There's also these two scripts basically defining how I'm actually dealing with the ledger, storing the data on the client side in React-based stuff. So this is simply a context for, React context for just storing the data and refreshing the pool every time. And yeah, I think that's what I've got today for you guys. If I had more time, I would have went more, but just let me switch to this slide. So looking ahead, we're whenever the unshielded tokens, the unshielded ledger tokens are supported, we're looking forward to make a new version out of this. And contract tokens, whenever the contract calls are ready, we're going to also add more versions about it. So that was it from my end. Thank you. And please go ahead, check out the code and play around it. Thanks.
Thank you so much. That was really amazing. Thank you so much.
You're
The
welcome.
Luna Swap is an incredible example of what developers can build, and not just build nowadays. Like you have like things to look into, contract to see how things get implemented and all of that. And I'm excited to see more, even more projects like emerge from the community generally. Inspired by what they've seen today, now you all can scan the QR code on the screen. For the code, you can take a look at the code and see how things get implemented. Yes, we have it wrapped up on the screen right now. And also, we'll be like attending to like questions towards the end of this call. Because of time, we have like a bit more things to cover. And don't worry, Skanda will be here with us so to answer your question if there's any specific to the implementation you just saw. All right. So I now let's talk about like building your own project on Midnight, right? You've seen like the possibilities are endless, right? You can build anything, and in as much you understand like the foundation and also what you really need to know about building. But one of the things over the past few weeks and months, we've been working really hard to improve the developer experience for building on Midnight. And one of the biggest pain points we've heard from developers was the onboarding process and also getting started. But however, we started with improving our documentation aggressively and then making sure that we can take you from 0 to 1. I don't know if you can put on my screen right now. All right, perfect. Thank you. So, like, talking about taking you from 0 to 1, now you can just easily go to our docs and follow the getting started guide that we have. So today, I want to walk you through two things. The first, we've updated our getting started guide even more. It now includes like a lot of complete guide for deploying contracts and what you need to know end to end. We have also restructured the whole process flow in a way that it's more intuitive and easy for you to follow. Because from start, like loading up this page, you can just see get started, install follow through all of the installation required and everything. Then the second part is also I'll be introducing like an NPM package that we recently just announced. And this package is also to help simplify the process flow for even making this experience that you have today from the docs to minutes, right? Taking you from hours to minutes, right? So those are the two parts that we're going to follow or cover in this section of today's fireside chat. So let me get started by showing you the docs. As you can see on the screen, we have the installation part. You should be familiar with all of this right now. But if this is also your first time, joining our live stream, welcome, welcome once again. You can follow through the docs here for installation, create your wallet, link that directs you to everything that you need to get installed and everything that needs to be installed on your local machine. And not just that, but also like guides for setting up your proof server, Docker setup, running everything that you need to set up locally. Then after that, you can then move to creating the actual application, right? So in the actual application, you have a couple of prerequisites that you should follow for you to get started. And that is from the node version that you need to install, creating your project, and also a couple of contracts. So in this example, we have the Hello World compact example. Hello World is like the the most friendly way to introduce anyone to any concept, and that is why we have a very simple Hello World contract that you can find here. Yes, the contract session. And you can see that we also define the circuit. We're kind of explain what is going on under the hood for you, what you need to do to store messages, and how you need to write your contract. So this is an example of what it should look like. And then compiling the contract. Then after contract compilation, you can then go to development, because after writing, you compile. After compiling successfully, then you can go to deployment. In the deployment process, you have a couple of things to update. You just need to follow through the documentation. Like, for example, we need to update the existing package.json that you already have. And I think during our last two calls, we had like a very minor blocker during deployment, and that has also been fixed already. So, which means that you can directly copy things from the docs and then paste it into your local machine, your local Visual Studio Code or any editor that you're using, and you can run it right away. So you can see that we have like different steps for this particular deployment. One of them is to build up the script that you need for deployment. And we started with the package of JSON configuration to the TypeScript configuration, then gradually move into the actual file, right? So there are a lot of packages here that is used in this project that during this setup or deployment that you want to do, you might have to go through it and understand how it is implemented one after the other. But most importantly, following through the docs means that if you update your package.json with what we currently have on docs, you automatically have all of these packages highlighted. What you just need to do is to run npm install, and you should be good to go. Then we go ahead to configure the testnet configuration, set up the indexer, like put the RPC URL and also the indexer URL. And then after that, we created a very simple main function that allow you to set up what you need, particularly for wallets, to set up your wallet, and also building your wallet locally for that particular deployment to happen. And then finally, we created a part where we get an update after compilation and deployment, then a generated part. What is generated? The compiled contract is saved from the digs that you have locally, and then you can find the step where we actually do like the interaction for deployment. So if going through this, you can see we have like different blocks of codes that you can copy, and I'm going to tell you in the second part how to make this even better for you to understand. So now, after this part, what you need to do next is to test your deployment script, and then you can run the Docker command, to spin up your proof server locally, and then run build and run deploy. After that, you should see a contract deployment, a contract address, and a success message that completes the entire process. Then next, we want to, after deployment, we want to move to like interaction, right? For interaction, now you have a contract that you already deployed. You want to interact with that contract. Let's say you deployed, in this example, you deployed an Hello World contract and you want to store message, you want to bring back any message, like you want to read message on chain, all of those activities is what you will be doing here in interaction. It also has like different block of codes that help you for every action that you need to take, from loading the contract, compiling, writing, interacting with the contract to read what is currently stored on chain, and also to write on chain, right? So and also there's this part here, which is the interactive loop menu. So the way the CLI works is that it's running, up and running. What you just need to do is, if you want to store a message, you follow a prompt, and then you see that in action in a moment. When you follow a prompt, after that prompt, you do the next thing, and then it goes back, it creates that loop for you so that you can test it out of the box. So that's what we have on the docs today, from storing your message, reading your message, and everything that you can get access to right now. Oh, sorry, everything that is implemented on the contract, on this Hello World contract. So same applies to any other contract that you have, the process flow that you want to deploy with. But if you look at the entire flow here, we have like individual blocks telling you what they do and what you need to copy. Then we also now talked about like how do we even improve the experience for you to quickly get onboarded, and also getting started, like instead of like copying all of these things one after the other, which is good, but how do we make the experience even better for you? And so we recently announced, if any one of you have seen this, we recently announced like a very simple tool that scaffolds the whole experience I just showed you now in less than 5 minutes, like scaffold everything and also help you run everything out of the box. So what I'm just going to do quickly to show you how this works is we are going to, you can find the instruction here. It's well written on the npm package. But then what I'm going to do is I'm going to head over to my terminal, and then I'm going to run the command line. I don't know if my screen, yeah, I think it's audible. Maybe I can zoom in a bit. All right, so I'm going to run nps. So it's create mn app. So like we have on the docs, we have create your mn app, midnight app. So we kind of use the same thing. So it's, you're familiar with what the nomenclature looks like. And then I can name it as, let's say, my tests app.
I'm sorry, I may need to make it a bit bigger, the terminal.
Oh, okay. Thank you. Thank you. I'm trying to zoom in. I think I can't. Okay. I can still go higher. All right. I think, is it better now? So I'm just going to start that. All right, cool. So let me start that all over. So you can create, like, just run the command, create MN app, then name it whatever you want to name it. And then this would ask you. So the interesting part is that we have so many examples, right? You just saw the Lunar Swap demo, you saw like a couple of, and there's still lots more. We already have the ERC20 token example, the ERC721 example, the ERC1155 example on Open Zeppelin. So one of the long-term goal for us for this particular project is to have examples that you can scaffold quickly to see how things work and then run it locally. So you don't have to look for all of these examples where they are. Once you have access to this package, you can just clone and then pick any starter template that you want. So in this case, for this demo, we have Hello World and the counter app, right? You can see the bulletin incoming, decentralized exchange incoming, midnight. It's like a lot of libraries that we plan to add all of the starter templates here so that you can just spin it up out of the box. So for this demo, I'm just going to click on Hello World, and this is going to create a project structure for me, as you can see, and then it generated a wallet for me. During the midnight, if you're trying to interact with the midnight, you're trying to deploy the midnight contract following what we have on the docs, you see that there's a part where you see your seed phrase being printed on the terminal and also your wallet address. So we've bundled it in a way that it can get generated for you automatically in your environment variable, so you don't have to expose all of that anymore. Everything gets set up out of the box. So now you can see this is up, success your Midnight app is running, and you can also find the instruction on what to do next. After that, it says you should cd into test app, which is the name of our app, and then run setup. But then you can also see available command for you to check. So what I'm going to do now is to cd the test app, and then I'm just going to open this so we can see the content of the file. So this is going to be small, I'm sure. Okay, so I'm going to zoom in so you can see. So now we have so this is what the package spinned up for us. You can see a full-blown project with our EMV example and also the test app. So this is the content. We have the contract, the hello world contract already written for us with a clear comment on what each and everything, on what is going on with this contract. So same applies to the counter app, same would apply to if we had, for example, the Lunar swap contract directly in this example. Same applies to the ERC20 token example also. And then inside the source folder, this is where it gets really, really interesting, because inside the source folder, you can now see providers, right? You can see a bunch of codes. So, and then you can see things in the utilities folder where we set up the environment. Typically, everything you copied during the process on the docs where you're trying to spin up your hello world, right? So these get bundled for you automatically. And of course, you can, if you want to learn how it is done, you can just go directly and see how it is implemented and replicate the same thing in your own application if you would ever want to follow this pattern. Right. And then the deployment, we have the deployment.ts, we have the same CLI.ts, like everything gets bundled for you automatically. We didn't write any code, right? We only just ran a command to spin this up. So now that we have this, the next thing I want to do is, if you go to the package, in the README, you see the next thing you're supposed to do to install and then to run the setup. So what I'm going to do now is I'm going to head over to my Visual Studio Code, my terminal, and then I'm going to, I don't know if this is big enough. No, I doubt. But let me zoom in. Yeah. So the first thing I want to do, if you remember during the deployment example that I gave earlier on, we have the parts where we set up like the proof server locally and make sure that the Docker is running. So that's what I'm going to do here first. But with that, you can see it on inside the package.json file here. To start up your proof server, you just need to run npm run proof server, and then I can just go back and say npm run proof server, and then okay, sorry, I need to see the test app. Yeah, then clear, and then run, and then run and then run npm proof server. You can see spins up my Docker environment, like my Docker locally, and then start up the proof server image. So now we're done with that. We just need to go back to our application, and then the next thing we want to do is npm run setup, right? So now we've started the server, we just need to npm run setup. So what does setup do? This is going to compile the contract, and then it is going to build the wallet for us. It shows us the balance that we have right now. It shows us that the wallet needs funding to deploy contracts. So for you to deploy, you need to fund it. And then you also see instruction on what to do next, right? You can see it's waiting to receive token here, right? And the good part is that when I copy this address and then try to like fund it, you don't need to restart anything. You see the updates in real time here. So I'll show you that quickly. Sometimes it's really, really fast, like to fund. If you go to midnight.network/testnet/test/faucet, let me just refresh the page. This is what it's going to look like, and you can just paste in your address directly and then request for TDOS. Right. I've tested this multiple times. Sometimes it takes less than 1 minute, sometimes 2 minutes, sometimes. So it's a bit, in case you are experiencing maybe after you've gotten an acknowledgement on this site that it has been approved, and then you go back to your, terminal, the expectation is that the balance should be funded already. But sometimes it takes time. What you might want to do is to stop the app and then run npm run deploy again. This is going to check for you. So you know if it is funded already or not. You can keep it running and just leave it like that. But another alternative I would do here to see which one comes in first is I'm going to go to my list wallet. Okay, is this opening somewhere? 1 second. Okay, so sorry, this is opening in a different tab. So I'm just going to bring it here. Yeah. So another thing you can do here is to just fund it, and I'm just going to do that real quick. So now I can just go ahead and send some amount to this. Oh my God, sorry. To this particular wallet address. And then, so I'm going to send, let's say, I don't know, maybe 200 something. And then confirm. Yeah. And then it's going to like send. So all of this is I'm doing is just like for us to get the assets. So once the wallet is funded, it will be updated here. But while that is going on, let me see. Okay, all done. So you can either, depending on like the system you are on, Mac, Windows, or any operating system, you can as well just stop and start and run the deploy again to check if it has been funded or not. Sometimes it takes time. Oh yeah, so this is taking longer than expected. But yeah, so the plan is once we receive this fund, then we can use that to, that's deployment process completed. Then now we can use that to test our CLI to interact with the project, right? So that is like what I wanted to like show you all on what exactly it means for you leveraging this type of package to bundle your application real quick, and also show how you can install, compile, deploy, and still interact by just running that command line. If you choose not to like follow what is on the docs, this can also get you started almost immediately. So yeah, that's really, really interesting to see. And it's also open source. We are open to like contributions from anyone. Feel free to create an issue, open a PR. We'll be happy to like take everything, like happy to review, and then get any of the suggestion or improvement into the actual code itself. Thank you, everyone. I hope this gives you like a clear path to start building on Midnight. And the documentation and tooling will continue to improve based on your feedback. So please let us know what works and what doesn't work for you, or what does not really make any sense. So now I want to hand it over back to my colleague Jay to share some exciting updates from Hacktoberfest that we have.
Great. Aegis, can you hear me?
Perfect, loud and clear.
Awesome. So it's nice to see everyone. I go by Jay. If you're not familiar with me, I am a DevRel engineer over here at Midnight, and we kicked off Hacktoberfest a couple of weeks ago. So I wanted to go over that, go over the details on the winners, and share that with you all. But before I get into that, I want to just briefly say thank you to Open Zeppelin for coming onto the stage. That was awesome. It's going to be an amazing opportunity for our community to learn about dark pools, to learn about slippage. I had to learn the hard way by losing a lot of money. So if you're going into DEXs and you're starting to look into liquidity pools, highly recommend going through the testing so that you understand how this all works. And Idris, I deployed contracts using your docs as well. Earlier today, I sent the team a video on that. So thanks for uploading that. Awesome work. Now to get to the finalist for Hacktoberfest. As you can see here, we have 3 different winners. So let me open this a bit. We have Bo Chacho or Bo Chaco. I saw you submit a lot of PRs, gets a lot of feedback from us. It was amazing going back and forth with you and putting in those PRs and getting them approved. So thank you for your contributions. Next, we have Cardano Profit. You slipped in some updates at the ending. And Island Ghost Stephanie, you won as well. So congratulations to the top 3 winners for Hacktoberfest. We'll be sending out t-shirts. One thing I do want to note is that some of you did not fill out the information that we need to send you the shirts. So for the top 3, either reach out to me, or if I don't hear from you later today, I'll be reaching out to you for that information, and we'll get those shirts handed over to you. Now, along with Hacktoberfest, we worked on updating our contributor hub so that people can submit their tickets for the non-coding solutions. We realized during this process that there's some updates that we need to make, and we're going to make those updates so that you can get credit for no-code contributions, not only for Hacktoberfest, but for many of the things you're doing outside of Hacktoberfest. So we'll keep you up to date on that progress. But lastly, one thing I wanted to note from Hacktoberfest, and I'm sharing another screen now, are some of the contributions. So we noticed that a lot of the contributions included some of your code, some tutorials, and we thought it was an awesome opportunity to include those contributions in our docs. So as you can see here, this one was actually submitted by Bro Taco, who is the leader for Hacktoberfest. It's a step-by-step guide on how to create a React wallet connector so that you can connect a wallet directly to your interface. So not only did we push this one out, but we have a tutorial that I pushed out for Next.js. And for many of the people who are asking about NFT contracts, one of our other community members also submitted a write an NFT contract. So we have a ton of different docs and tutorials that came out of this. We loved all the work that you've done, and we're going to continue to launch sprints going forward. So if you participated in Hacktoberfest and you saw this sprint here, we're going to spring up a lot more leaderboards for you to participate in, for you to win prizes if you come out in the top 3. So check out Zealy. Tune back in frequently to look for these sprints that'll be time bound. They'll end at a certain time. And it's an opportunity for you to continue contributing, continue to be rewarded for your work. So that's all I wanted to cover. And I want to thank you for bringing me on the stage, Idris.
All right, thank you so much, and huge congratulations, big congratulations to everyone that participated and our top 3. We have a lot more to share, like Jay mentioned, and we'll also be creating this kind of sprint for everyone to participate. And of course, outside Oktoberfest is over, but we are still open to contributions. Please feel free to contribute. Feel free to create an issue. Pick up an issue. Send a PR. We'll be happy to review and get all of those in. So I think we have a few more minutes to go for questions. I think we have a couple of them. Maybe I'm not sure. I have to go through. But by the way, if you have any question, please feel free to ask. This is the best time to ask. So I'm trying to read through if we have anyone. Okay, yeah, so there's a question for you, Skanda. Can you see the screen? Okay, good.
Right. I'm not sure if I understand it. What do we mean by nomen cloud?
So
sure if
I
I
think I
understand
can
it,
step
sorry.
in here. I've seen this actually on the forum, and Lewis proposed this. He's mostly asking about whenever we're writing, let's say, our libraries or circuits, whether we're using like Camel case, whether you're using Pascal case, there's not a standard across. So it's something that if you have feedback on, it'd be great to provide.
Yeah, okay. Sorry, I think it's Pascal, like TypeScript conventions we're trying to do with everything, with namings, and even with the TS docs. Like we're trying to follow the same docs in the TypeScript format. how we organize the module, etc. I think also the compact team, the language team, are having this in their mind to design a language a bit similar to TypeScript. I hope that answered the question.
So I'll respond in the form after. But yeah, we discussed the Pascal case. Some of the docs may not be following that. We're aware that we have to set the standard and then update our docs. So we'll keep you up to date on that.
Yeah, I may say something here. Like sometimes I figured out by experience for witnesses, especially, we got to put a prefix before, like wit, and then underscore, and then the name of the function. Because if you just leave it like this, like many people just write secret key as a witness function and then use it inside a circuit. But then when you read the circuit, you actually can't recognize if that's a normal circuit or it's a witness thing, which are so different things. So we used to put just witness underscore and then the name. That's just the convention in my team.
All right.
And
Yeah.
everything is open source.
Yeah. Everything is open source. You can find the contract. We'll share the link. We'll share again. Yeah.
Yeah, that's just this thing token.
Do we want to cover why it's wrapped PTC?
No, it's just from my head.
Yeah. I think okay, we have another question. I think this is direct.
That's for me.
Yeah, yeah.
Yes, I am. I think I'm in the diff chat. Maybe I'm not active there, but I am there.
Okay.
You can. I think the same username as GitHub is my username too. Well, I need to double check. I can. Let me guys check now. I'll share it here. How to write in the chat. Maybe I'll post it here and you guys can share it later.
All right. I think that's all from the question side of things. I also want to thank everyone for joining today's Dev Hangout. We have this weekly, so we'll see you next week. But before then, I think we've been sharing like a couple of resources that you should check out. Check the Lunar Swap repo, the Midnight, sorry, the contracts repo from the OpenZP, which is the Midnight apps. You can check that out too. And of course, to get started, once again, yes, we have the QR code you can scan to get started. And the other side is we have the documentation that will keep improving, and you can check that out and get started with that, like make use of that. And then finally, the NPM package that we created recently, it's available today for use. We'll be improving it a lot more over the coming weeks. You can also scan the QR code like to join. And also, if you have any follow-up question, we want to connect with you all. Please connect with us. You can find us on Discord, on our community hub, or reach out directly to any of us, like on any platform that you find us very active on. Thanks again for joining. I'm really excited to it's really, really interesting for all of the things that we covered today. Happy building. See you in the next one.